The smooth way is known as a band winding system. It's formed like a twisting with a straight bar across its middle. Around 66% of the cosmic systems in the realized universe are twistings, and around 66% of the winding worlds are banished, making the smooth way one of the most widely recognized sorts of cosmic systems. Twistings like the smooth way have arms that loosen up from the middle like wheel spokes and twist back around the center point. Our planetary group is roosted in the focal point of one of those spokes, the Orion Arm. The Orion Arm was once thought to be a spike, a minor bulge contrasted with significant arms like the Perseus Arm and the Carina Sagittarius Arm. In any case, it's as of late been recommended that the Orion is really a part of the Perseus Arm and doesn't start in that frame of mind of the universe by any means. The issue is, it's difficult to get a reasonable image of our system, as a matter of fact. It's a similar explanation you can't see California from Beverly Slopes. You're excessively submerged for point of view. We can see the things that quickly encompass us and judge the general shape, and our situation inside that shape in light of our restricted perspective. For what it's worth, our spot on the Orion Arm is nearly 550 parsecs from one or the other edge of the arm and around 8,000 parsecs from the focal point of the cosmic system. 1 parsec is generally 30.9 trillion kilometers, 19.2 trillion mi. We're just about as confined as anyone might imagine. 10. The Orion Arm. The smooth way is known as a band twisting world. It's formed like a winding with a straight bar across its middle. Around 66% of the worlds in the realized universe are twistings, and around 66% of the winding systems are band, making the smooth way one of the most well-known kinds of worlds. Twistings, like the smooth way, have arms that loosen up from the middle like wheel spokes and twist back around the center. Our nearby planet group is roosted in the focal point of one of those spokes, the Orion Arm. The Orion Arm was once viewed as a prod, a minor distension contrasted with significant arms like the Perseus Arm and the Carina Sagittarius Arm. Nonetheless, it's as of late been recommended that the Orion is truly a part of the Perseus Arm and doesn't begin in that frame of mind of the system at all. The issue is, it's difficult to get an unmistakable image of our universe, as a matter of fact. It's a similar explanation you can't see California from Beverly Slopes. You're excessively inundated for viewpoint. We can see the things that promptly encompass us and judge the general shape and our situation inside that shape, in light of our restricted perspective. For all intents and purposes, our spot on the Orion Arm is around 550 parsecs from one or the other edge of the arm and around 8,000 parsecs from the focal point of the cosmic system. 1 parsec is generally 30.9 trillion kilometers, 19.2 trillion mi. We're just about as disconnected as anyone might imagine. 9. Supermassive dark opening. The littlest supermassive dark opening we've determined has multiple times the mass of our Sun. Contrasted with a customary, heavenly mass, dark opening, which has the mass of around 10 suns, that is a decent size. Yet it doesn't compare to the supermassive dark opening arranged at the focal point of the smooth way. For the beyond 10 years, cosmologists have been following the movement of stars in circle around Sagittarius AI, articulated A star, the thick district in our system's winding. In light of the way those stars are moving, they've discovered that in Sagittarius A, taken cover behind a thick dust storm and gas, is a supermassive dark opening with 4.1 million. This liveliness shows the real developments of the stars around the dark opening from 1997 to 2011 inside a cubic parsec of the focal point of the world. At the point when stars draw near to the supermassive dark opening, they slingshot around it with mind-blowing speed. One of the stars, shown, S02, is moving at 18 million kilometers, 11.2 million miles, each hour, as the dark opening's impact pulls it close and shoots it out the other side. And all the more as of late, we've seen a gas cloud approach the dark opening and afterward be destroyed by the opening's enormous gravitational force. As bits of the gas cloud get sucked in before different parts, the cloud spaghettifies. It extends into staggeringly slim strands in excess of 160 billion kilometers, 1999 billion miles long. 8. Molecule springs. Notwithstanding a monster, matter-sucking opening of blankness, the focal point of the smooth way is likewise the area of a tremendous measure of action. Stars are biting the dust and blasting to life in a steady cycle. Furthermore, as of late, we've seen something different emerging from the cosmic center point, a surge of high-energy particles that stretches more than 15,000 parsecs across the world. That is the greater part of the whole width of the smooth way. They're undetectable to the unaided eye, yet with attractive symbolism, the molecule fountains should be visible across close to 66% of our sky. What's causing the peculiarity? 100,000 years of star development and rot, filling a ceaseless stream crawling towards the world's external arms. The complete energy in the fountain is more than 1,000,000 times that of a cosmic explosion, and the particles are going at supersonic velocities. What's more, it's not irregular. In light of the design of the molecule jets, cosmologists are building a model of the attractive field that oversees the whole system. 7. New stars. So, exactly how frequently is another star naturally introduced to our cosmic system? That is the issue Dr. Roland Diehl and a group of cosmologists have been attempting to sort out for quite a long time. They've been planning the presence of aluminum-26, an aluminum isotope that into space. North of a huge number of years, those particles gather into subatomic mists, which in the end become so thick that their middle implodes under its own gravitational force and structures another star. It resembles an environment, passing feeds life. The particles in some random star were a possible piece of billions of different stars sooner or later. The way that the smooth way is dynamic like this drives its compound advancement and prompts the development of new conditions, expanding the likelihood of planets with Earth-like circumstances. 6. 100 billion planets. Notwithstanding every one of the passings and births of stars in the smooth manner, there's a consistent aggregate, around 100 billion. Furthermore, in light of another review, it's accepted that there's something like one planet for each star drifting around out there, and presumably more. At the end of the day, there are somewhere close to 100 billion and 200 billion outsider planets in our edge of the universe. The scientists who reached that decision concentrated on a solitary sort of star known as M diminutive people. These are more modest than our Sun, and they make up approximately 75% of the stars in the smooth manner. Specifically, they watched Kepler-32, a generally close by, M smaller person with 5 planets in its system. Planets, not normal for stars, are hard to identify on the grounds that they don't emit their own light. The main time we can recognize a planet, without a doubt, is the point at which it goes between its Sun and Earth, making a little dim spot. Kepler-32's planets follow a couple of explicit ways of behaving that have been seen in other exoplanets around M diminutive people, to be specific, comparative size and distance from the star. In view of that information, they transformed Kepler-32 into a model for planetary event across the galaxy. It's not precise, however, as one specialist put it, it resembles a language, the language of planet development. Utilizing the Kepler model, they can read some random star to decide the probability that it harbors planets. 5. Billions of Earth-like planets. 100 billion planets is, in specialized terms, a ton of planets. Yet what number of those are like Earth? Generally talking, not much. There are many various sorts of planets, gas monsters, pulsar planets, earthy-colored diminutive people, and planets that downpour liquid metal from the sky. Indeed, even the ones made of rock are typically either excessively close or excessively far away from their star to help whatever would look like life as we're utilized to it. However, the consequences of a new report uncovered that there could be more than we had recently suspected in our universe. Gauges run between 11 billion and 40 billion. Scientists took an example of 42,000 stars that were like our Sun, then, at that point, set out searching for exoplanets inside the legendary Goldilocks zone, named after the fantasy, not over the top hot or cold, yet just right. They found 603 exoplanets around those stars, and 10 of them fit the bill. Analyzing information from the stars let the researchers find the presence of billions of comparable planets that we've yet to find formally. Hypothetically, these planets can keep up with the right temperatures for fluid water, which would work with the generate of life. 4. Barbarian universe. Regardless of how frequently a star is conceived, it's basically impossible for the smooth method for developing on the off chance that it doesn't pull in that frame of mind from somewhere else. Furthermore, the smooth way is most certainly developing. However we beforehand didn't know precisely the way in which that development was going on, late discoveries proposed that the smooth way is a barbarian. It has drunk different systems previously and will most likely keep on doing as such, basically until a bigger world goes along and maneuvers us into it using the Hubble Space Telescope and data from around 7 years of photographs. Scientists found stars along the external edge of the smooth way that were moving digressively. Rather than moving either toward or away from the smooth way's center, similar to each and every other star, they simply kind of floated along sideways. The star bunch is accepted to be a remainder of one more world that was consumed by the smooth way, pieces left over from its last large meal. That impact probably happened billions of years prior, and it won't be the final remaining one to occur. At the rate we're moving, we'll probably eat the Andromeda system in around 4.5 billion years. Really awful, not a solitary one of us will be around to see it. 3. Grandiose distorting. Albeit the smooth way is a twisting by definition, that is not a completely precise method for mulling over everything. There's really a lump at the focal point of the system, so the entire situation kind of seems to be a flapjack with a heap of whipped cream on each side. The twisted area is the consequence of hydrogen gas atoms extending away from the two-layered plane of the spiral. For years, cosmologists were confused by the apparently odd distorting. By all rationale, the gas ought to be pulled toward the plate, not away from it. The more they concentrated on it, the further the secret ran, on the grounds that the particles in the twist are not just pulling endlessly, they're vibrating at a recurrence of their own. So what's causing it? As may be obvious, dim matter and a pair of little universes known as the Magellanic Mists. At the point when they're assembled, the Magellanic Mists have around 2% of the smooth way's mass, sufficiently not to influence it much. However, when dull matter travels through the mists, it makes swells that obviously influence their gravitational draw on the smooth way. This reinforces the force and tempts the hydrogen away from the focal point of our galaxy, and it gets considerably more odd. Magellanic Mists circle the smooth way, so as they make every transformation, the twisting arms of the smooth way fold because of their presence like a banner waving in the breeze. E2, twin universes. While the smooth way may be special in numerous ways, most would agree it's not precisely uncommon. We previously referenced that winding systems would one say are of the most widely recognized types known to man. Add to that the way that there are around 170 billion noticeable universes, and it couldn't be a stretch to envision that there could be a couple of worlds out there basically, the same as our own. But what might be said about one that is very nearly a precise reproduction of our own? In 2012, cosmologists found a world that imparts a similarity to all that we are familiar the smooth way. It even has 2 little satellite worlds circling it, completely relating to our own Magellanic Mists. Furthermore, that is intriguing. Just 3% of winding universes have buddy systems like that, and they don't keep going long. The Magellanic Mists will presumably scatter several billion years,